Okay, so a friend of mine at work, Mark, asked me to show him how to wire up this micro switch. He gave me one of these things to embed in a project, and he said that he would like it if I showed him how to wire it up and get it to work with an Arduino Uno. So here it is. It's pretty simple. What we have here is we have, I guess I'll show the micro switch first. This micro switch, if you look right here, you'll be able to see that it shows the pole 1 and pole 2, and so we have this common up here, and down here are the two that you switch to. So I'll show you right there. Switch, and it turns on this LED. I'll show you how that's wired up. So this white goes to the common, is following all the way around here to 5 volts. You can see that that's 5 volts. Over here goes into the 5-volt pin on Arduino. See if I can get that to work. That. So it's going into 5 volts. And then we have this black wire that's going into ground, and over here it's blue. And we have this green wire, which is going over to the 2 contacts for the micro switch. And it follows it around, and it goes to, basically hooks up to this green wire, which goes down to pin 2. And you can also see that we have a pull down resistor right there. So it goes both to ground from that resistor, which is the pull down resistor, and then it also goes to pin 2, which is the input we're using in our sketch. And then another thing we have here is on pin 13. We have a jumper going over to here, which is connected to this LED, which is going through a current limiting resistor there, which goes to ground. So when pin 13 goes high, then we get the LED to turn on. So I'll show you that. And it also, you don't notice it flicker much. It doesn't, it waits for it to turn on. You can also notice that the LED on pin 13 on the Uno is also going. The sketch I'm using is the example debounce sketch that comes with Arduino. It's pretty straightforward. I'll also show that on this micro switch that, let's see, contact, oof, it's hard to read. Maybe I've got it upside down. I don't know. Yeah, it looks like it. 1, 2, and 4. So it looks like 2 is normally connected and 4 is not connected when the switch is inactive. So when you push that, it connects with contact 4, turns the LED on. So now I'm going to switch, if I can do this with one hand, to the other contact. back to 5 volts. Okay, so now you can see that the LED is on when the switch is not depressed. Oops. Ah. Alright. So when the switch is not depressed, it's on, and when the switch is depressed, it turns off. So it's the inverse. And there you go. I'll go ahead and also show you the sketch here. Let's see, I guess we'll just do it this way. Let's see if I can get that on the screen. So, you'll notice the way this is set up. I'm just using the default sketch here. That we have. Oh wow, that's weird. Alright, that's better. So setting up button 2, button pin is pin 2. Setting up the LED state is high. So it says the current state of the output pin, and it sets it at high. Last button state low. Has a debounce delay of 50 milliseconds, I assume it's milliseconds, we'll find out. And then it just sets up the input and outputs for those pins. And let's get this. There we go. Great. So in the loop, it takes a reading of the button, and then it checks the reading and sees if what the last button state was, and it says if the reading is not the same as the last button state, it'll check or it'll set the last debounce time that it saw to the current milliseconds to see how long it was since the last time it tried to debounce. And then it says if the milliseconds is current milliseconds is minus the last debounce time is greater than the debounce delay, it's going to say, okay, actually apply the reading to the button state, and then it's going to change the LED pin to whatever the button state was, whether it was high or low. So when we were using pin 2 as the default, which was the on the micro switch. So when pin 2 was the default, let's see, get in there. Focus. Anyway, so the one that's normally connected, it stays on. So the button is considered to be on. When we did it the other way, when it was connected to pin 4, button state would have been low. So setting LED pin low turns it off, and in this case, and high turns it on. We could have switched that around, and then it says here it's setting the last reading, or the reading for the last button state, the last thing it saw, regardless of whether it's debounced or not, and that helps it figure out what to do with the next time it goes around the loop, where it can check this again to see if the button is bouncing up and down. So yeah, that's about it. Hope you like this, Mark. All right.